G'day everyone and welcome back to my channel. In this video we're going to take a look at a linear regulator, but it's not going to be one of the LM series bog standard ones that you'll see in just about everything. Some of you may be familiar with this series of regulator, or you may be familiar with the series above this regulator. This regulator actually has three different series in it, and then there's one above that which is actually a low dropout. Now what makes this regulator interesting is that it's got quite good regulation, and it's almost a low dropout regulator but not quite, but it still does better than the lt1083 series with a 2 volt dropout voltage. I'm not sure if they're all 2 volts, but I know the 5 volt one, I think it is 2 volt dropout. But anyway, let's go have a look at the data sheet and see what I've got. So there it is. It's by Linear Technology, and it's the lt1083 that I have here, which its claim to fame is its output current. So obviously this is designed to be used with a fairly low dropout voltage. So if you're not putting a very high input voltage into it and you're requesting, almost the same voltage out as what you put in, with ample heat sinking, you can actually get 7.5 amps, which is quite a bit for a linear regulator, especially in a TO220 package. And as I said, the line and load regulation, I haven't mentioned that yet, but I was about to. It's very, very good. So again, this is probably a lot better than a 78 series, 79 series, even though they are good devices. I'm not mocking them. Anyway, actually let's have a look at a data sheet for one. So what's the regulation on a 7800 series regulator? I don't think that's as accurate. I'm not good at math. I'd have to sit down and work out the math for this and then use a calculator to work that out. But as you could see, it was specified in millivolts of drift over a different input voltage range. I doubt with a line regulation of 0.015% and load of 0.1%, I doubt that's going to drift much. Although the load regulation isn't as tight as the line regulation, but because of both, yeah, this thing's going to have a pretty good stable output. We can test that. I'm just pausing so everyone can get a read of this paragraph. Alright, so older packages, current packages. Wow. Load regulation's nowhere near as tight as the line regulation. I'm curious if that's just how the regulator works, if it has more, it achieves better regulation that way, basically, is what I'm trying to say. So we can see its behavior, how it regulates, how it handles loads, short circuits, dropout voltages. Quite cool. Temperature stability, ripple rejection. Cool. So that's the internal block diagram. I'll make sure I leave all of these parts of the page on screen, so if someone wants to pause and have a read, you can. Quite an interesting part, and it's very well documented in the datasheet. And there you go, typical application. Interesting example. So it looks like they're using the output of it for a reference. What is going on here? Huh? Wait. Is something oscillating here, or... This is an interesting circuit. I'm going to have to study this for a minute. No, that is what I was thinking this was something to do with pre-regulation with a reference and SCR, but yeah, it is. It says right here, I just didn't read the writing. So that's really cool. It says general purpose regulator with SCR pre-regulator, which is what's going on here. Driven by these op amps, looking at the output here, comparing it against reference here. And, oh, yeah, so it's not using that as a reference, it's using that as a reference. Comparing the output against that and adjusting the SCRs, which it's firing through this transformer. That is a nice little interesting circuit. We could build that up if anyone's interested. It is late. Excuse me. Yeah, if anyone wants to see it, leave it in the comments down below. I will build this circuit and we'll give it a test. Have a look at the performance of it. That would make for an interesting video, I reckon. Let's continue. Wow, remote sensing. Wow, that's cool. I wouldn't mind having a look at that too. That's why I picked this part, because I figured this is going to make for quite a few videos to come. There's a lot that we can do with this thing. And, you know, I want to leave it up to you guys too. Leave it down below what you want to see. You've already got some ideas here. If you want to see any of these circuits, leave it down below. I mean, I'm already going to build some of these in upcoming videos, but, you know, if anyone's got any other suggestions or really wants to see something, or maybe wants to try something slightly different with one of the circuits that's in here, leave it in the comment section. Alright, let's go take a look at this guy. So that's the part. And that's what it looks like. I've just set up one of the test circuits in the data sheet if anyone's curious what we're looking at here. If I can get this. I think it was about 7 volts, I can't remember, I didn't have the exact resistor values. 4.7, that's right. It was supposed to be 5 volts, but I've used the 330 ohm resistor and a 120 ohm resistor. I needed a 365 ohm resistor and a 121 ohm resistor. Well, it's up and running. I'm going to go back to the power supply and wind the voltage all the way down to, say, 5 volts and wind it all the way up to 30, and we'll see how this regulates. So that's at 5 volts roughly, just a bit more. I'm going to wind it up to 30. That actually changes about the same amount as the lt1083 that we looked at in the last video. Actually, that changes a little bit more. Although, no, it changes the same amount, 2 millivolts. I'm back down at the bottom end. It's 4.708. Let's go up 9, 10. Yeah. So that's got the same precision as a lt1083, if anyone's curious. Well, at least for line regulation. All right. I'm just thinking if I should build one of these circuits quickly in this video, or if I should leave it for another video. I've just been having a look at these different circuits, and I think what I'm going to do is solder a few of these on some proto board, and we'll have to play around building the circuits up on proto board, because some of these will be easy to do on breadboard, but some of them not so easy. So yeah, again, like I said, if you want to see anything in particular, please leave it in the comment section and I'll definitely visit that. Alright, well that's all for this video. Thanks for watching, and please give me a like and a sub if you like my content and if you like the videos and the channel. It will help me grow. Alright, I'll see you all later. Bye.